Hello people, this is the mark scheme for the potential paper 2 for A-level Pure Maths I posted earlier. So question 1, so we had to prove root 7 is irrational, so you just let root 7 equals A over B for A, B who do not have common factors, and then you write 7 equals A squared over B squared, so 7B squared equals A squared. That means A squared and A is a factor of a multiple of 7, so A squared has to equal to something like 7n squared, so that means 7b squared equals 49n squared, so b squared equals 7n squared, so therefore b squared and b is a multiple of 7. So if a and b are both multiples of 7, it contradicts the fact that we assumed a and b have no common factors, so therefore by contradiction root 7 is irrational. If you want to go through the proof thoroughly, just read through it. Question 2, so 8 minus x to the minus 1/3, you expand it out and you get half plus x over 48, x squared over 576 plus 7x cubed over 41,472. Question 3, f of x equals cos 2x plus ln x, so f of 1.9 is minus 0.149, which is negative, and f of 2 is 0.0395, which is positive, so there is a change of sign. Therefore, there's a root in the interval 1.9 to 2. And part 2, you just use the Newton-Raphson formula. So first of all, f dash x is minus 2 sine 2x plus 1 over x. And then x1 turned out to be 1.98042, and x2 is 1.98015. Okay. So question 4 is the Trapezium Rule question. So you just simply complete the table and work out the value. So it is 2.59984 decimal places. Question 5 is just a very simple question. So I got AB to be 2 times 1 2 minus 3 and AC to be 1 p plus 1 q minus 5, and then you get p equals to 1 and q equals to 2. Question 6. So g of 5 is 5 and f of g of 5 is f of 5, which is ln 21. And part B, f inverse of x is e to the x plus 4 over 5, and domain is x, all real numbers. And finally, so we got C, which is sketching the graph, which I have done here. I sketched g of x first and then I did the modulus. So in the corner here, in the left hand side, you can see I kind of worked things out. And we got 6D, so modulus of gx equal to 3. So you can see from the sketch, it has two solutions, so I solved it. So you get x equals 17 over 3 and x equals minus 1/3. Question 7. So A15 is 2.98 times 10 to the minus 6, or you could write it in decimals if you like. Part 2, 3,200 over 3. And part 3, you get k equals to 5, so you had to really go through the solution there thoroughly just to see how I got that, okay? And then we got question 8. So I let f of x equal to cos x, so f dash x is limit of h going to 0 of f of x plus h minus f of x over x plus h minus x, and then you expand cos x plus h, and then you very carefully cancel, and you get minus sine x. Question 9. So you do the partial fractions where you get a equals 1 and b equals to 1, and then integral of 6 over 9 minus y squared dy equals to integral of cot x dx. So that's same as integral of 1 over 3 plus y plus 1 over 3 minus y dy equals to integral of cot x dx, and then you just integrate them. I wrote everything in terms of ln, so ln 3 plus y minus ln 3 minus y equals to ln sine x plus ln k. Put ln k instead of c because everything's ln, so I could combine it. So ln 3 plus y over 3 minus y equals to ln k sine x. So you can get rid of the ln, so that means 3 plus y over 3 minus y equals to k sine x. But we know when x equals to pi over 2, y is equal to 0. So if y is equal to 0, we get 3 over 3 on that side, which is 1. And on this side, sine pi over 2 is 1, so k equals to 1. So therefore, 3 plus y over 3 minus y equal to sine x would be the solution. So that is question 9. And question 10. So we got x equals to 6 root 3 sine t cos t. I changed that to 3 root 3 sine 2t for easier differentiation. And also y is equal to 3 minus 3 sine squared t, which is 3 cos squared t. So dx dt equals to 6 root 3 cos 2t. dy dt equals to minus 3 sine 2t, well, minus 6 cos t sine t, which turns out to be minus 3 sine 2t. So dy dx equals dy dt times dx dt, and that works out to be minus root 3 over 6 tan 2t when you simplify. So alpha equals to minus 1/6 and beta equals to 2. Question 2. So when t equals to pi over 3, x works out to be 9 over 2, y works out to be 3 over 4. So I just, and then dy dx works out to be half, so m of tangent is half as well. And you just basically put in and you get y equals half x minus 3 over 2. Question part 3. So you just, I just made x squared equals to 54 sine squared t cos squared t. And I made y over 3 equals to cos squared t. And I just plugged it in because sine squared becomes 1 minus y over 3. And then you end up getting x squared equals to 18y minus 6y squared. Hope you understood that. Now let's go back to question 11. So y e to the minus 3x equals 3x plus y cubed. So when you differentiate that, you get e to the minus 3x dy dx minus 3y e to the minus 3x equals 3 plus 3y squared dy dx. And that simplifies dy dx equal to 3 plus 3y e to the minus 3x over e to the minus 3x minus 3y squared. And then you work out the dy dx and then m of normal, and then you just plug it in and you get 3y minus x minus 3 equal to 0 as the normal. Question 12 is a big one. So you get, what I did here, I just put everything under sine 2x, 1 over sine 2x denominator. So you get 1 over sine squared 2x minus 2 cos 2x over sine squared 2x as well, and then cos squared 2x, and then what I did is you can see the numerator here is 1 minus cos 2x whole squared over 1 minus cos squared x, and I just defactorized the bottom, cancelled it, and then you end up with tan squared x. Okay, I use the formulas cos 2x and cos 1 minus sine squared x and cos 2x equals to 2 cos squared x minus 1 to simplify. Question 12 part B. Okay, so you got cosec 4 2 theta minus cot 4 2 theta equals 1 minus cot 2 theta. 2 theta between minus 180 to 180. I doubled it because theta is between minus 90 and 90. So I did difference of two squares, and you can see from the formula cosec squared 2 theta minus cot squared 2 theta equals 1, and I just simplified it further. You get everything in terms of cot, and you get 2 cot squared 2 theta plus cot 2 theta equals 0, and then you get cot 2 theta equals 0 or 2 cot 2 theta plus 1 equals 0. So tan 2 theta equals 1 over 0 or tan 2 theta equals minus 1 over 2. I did not ignore the 1 over 0 because tan infinity exists. So 2 theta equals to tan inverse of 1 over 0, which is 90 and minus 90. And the other 2 theta is tan inverse of minus half, which works out to be minus 26.6 and 180 minus 26.6. And then the answers are minus 45, 45, 13.3, and 76.3. And then finally we go to question 13, which is quite simple. You prove that P lies on C, and then you just work out dx dy, and then you work out dy dx by flipping it, and then m of normal is root 3, and then you just plug it in. Okay, I hope you got it right, guys. If there's anything you don't understand, just pause the video and go through the working. Okay, good luck on Monday, on Tuesday.